Hello, beautiful people. Hello, Uche Osaz. How are you? I hope you're doing good. Thank you very much. Are you enjoying this pandemic? I hope you are quarantined. Okay, you are in self-isolation. You don't know what's going on outside. How would you know? You won't know. You won't know because you are meant to stay indoors, right? But I know, as a football player like you have very good space outside where you can exercise yourself. I saw the video your mom posted where she was discovering her talent on how to play football. Well, I won't say I envy her, but she has discovered her talent. I hope she will not keep it somewhere after the pandemic. But you know, they say difficulty brings out the best in you. Frustration brings creativity. So at a point where you don't know what to do any longer, it's best you start looking for solutions. The best way to face problems is not to shout and wail and let everybody know you have problem. No, it's to sit up immediately and fight the problem heads on. The worst that can happen is you lose your life. That's all. So as much as there's some strength in you, develop the courage, the bravery, and do what you have to do. After all, if you don't do it, you are still the one to complain that you still have a problem. So why don't you try out different solutions and see the one that works? One solution leads you to another. So it's a solution. It's a solution. And you know that there's no permanent solution to problems, because nobody can have it all. Nobody can have it all. It's either you have this or you have that. Nobody has it all. Nobody, no matter who you are. So whatever you can do, you do. So let's move on. Let's carry on with our topic for today, and we call it circle theorem. Most students fear this topic a lot. Yes, most students fear this topic a lot. Well, you see, one thing about fear in mathematics is that until you have tried it, then don't be afraid of it. That is the truth. Until you have tried it, there's no need to be afraid. Alright? So people have tried it and succeeded. There's nothing, as humans, there's just nothing you cannot do. That you cannot do it is meaning that you have not been taught to do it. You have not known it does not mean that you can't do it, but you've not been taught to do it. Alright, so be determined, but I would tell you that as much as the fact that you pay attention, you are going to understand this part of geometry. So it's called geometry, right? Alright, so let's go. So there are theorems. So all we need to do is to try to. So in today's class, we are going to be looking at 7 theorems. They are theorems. Theorems means they have been discovered, tested, and it's like that. So they cannot be disproven. So they have been proved to be something that can be used over time. It's like a law. The law has been made, except for if the law has to be changed, it takes a rigorous process that might take years to handle. So theorems are things that have been proven right, and you can test it and it can work for you. It's conventional, it's everywhere, it's general. Alright, just like SI units. Alright, so the first theorem that we are going to check out is one I would write on the board. So the first theorem says angle at the center is twice that at the circumference. So for each of them you have diagrams attached to them. So angle at the center is twice the angle that is at the circumference of a circle. So let's look at what that really means. So you draw a circle. I hope I tried in drawing a very good circle. So look at something like this. Then you have this. So you have this angle at the circumference. You have another at the center of the circle. Alright, so if here is x, here is 2x. That's what that means. That's the first law. That angle at the center is two times that angle at the circumference of the circle. That's the first law. It's like that. So if you have 100 here, what you have here is 50. That is just what they are saying. That's the first law. Okay, I hope it's clear. I hope you're getting it. Good. So let's look at the second theorem. So theorem 2 states that the angle subtended at circumference by a semicircle gives 90 degrees. So let's draw something like this. Let's draw a semicircle. So this is a semicircle, and you have this. So this gives you 90 degrees at this point. Remember, this is center, or sorry, we didn't draw this diagram properly. We're going to redraw it. A semicircle is half of a circle, please. So let's imagine you have something like this, then and you have that. So this is your 90 degrees. Alright, so the angle subtended at the circumference by a semicircle gives 90 degrees. That is the second theorem. Anyway, let's go to the third theorem. So the third theorem, so theorem 3, speaks of when you have tangent and radii so tangent and radii meet at 90 degrees. So what is a tangent? So let's draw a circle to show us what a tangent. So a tangent is a line that touches the tip of a circle like that. So this is your tangent. So if you have a radius like that, so they meet at 90 degrees. So this is what we're talking about. So this is the third theorem, that the tangent and a radii or a radius, they meet at 90 degrees. Right? Okay, let's go to theorem 4. Let's go to theorem 4. Theorem 4 says that tangents from a point have equal length. Tangents from a point have equal length. So tangent, what touches that line that touches the circumference. So if you have this and you have another one, so when they meet at this point, this and that are having the same length. So that is what is being spoken about. So that's theorem 4. The tangent, tangents, that line that touches the side of a circumference or of a circle, outside the circle, not inside, outside the circle. So when they do like that, their lengths are the same. All right, so let's go ahead to theorem 5. Let's go ahead to theorem 5. So the theorem 5, the law says that opposite angles in what is called a cyclic quadrilateral sum up to 180 degrees. So they both sum up to 180 degrees. They say it's a cyclic quadrilateral. A cyclic quadrilateral. So what does a cyclic quadrilateral imply? So let's draw a circle in this manner. Okay, so when we talk about cyclic quadrilateral, so it's a quadrilateral that is in a circle. So the quadrilateral, if you check, all of them are touching the sides or the circumference of the circle. So notwithstanding, as long as it is a quadrilateral that it's in a circle or a cyclic quadrilateral, you get the same results. So if for instance you have something like this, let's draw a quadrilateral like this. So let's imagine you have this and you have that and that too. So let's put the angles there. So let's number them. So you have A, B, you have C and D. So I use capital letters, right? Now notice that since it's a cyclic quadrilateral, that the opposite angles sum up to 180. So what they are trying to say is that A being opposite to C, angle A plus angle C is equal to 180 degrees. Same goes for angle D plus angle B will give you 180. You know very well that the sum of angles in a quadrilateral is 360 degrees. Notice that if you add the two 180s, you also get the same result. Now that is the fifth theorem for circle theorems, right? That is the fifth theorem. So having gotten the fifth theorem, remember how many we said we are going to discuss? 7 of them. We have 5. Let's go on with the sixth one. Now the sixth one says that angles So let's say this is theorem 6. So angles in the same segment are equal. So same way, you have a circle, you have angles in the same segment. So let's draw angles in the same segment. So you have this, so just draw a W, then you have that, then this one over there. So what are angles like that? So let's name them A, A, A. You see? So what does this look like? For me, it looks like a W or A, whatever you look at it as. So these angles are all equal. So you have A equal to A equal to A, maybe for clarification purposes. So this is the sixth theorem, right? Now let's get to the last theorem. The last theorem for circle theorems. Let's get to the last theorem for circle theorems. The last theorem this time for circle theorems. So this one is called alternate segment theorem. The alternate segment theorem. So we also remember we're talking about circles. I think I need to draw a better circle. I need to draw it. I've been doing badly these days in my drawing. So let's see what we're going to have. Okay. So imagine you have a tangent like that. So you are having this. Yeah, so it's supposed to touch this at the center. So from our information about alternate and corresponding angles, this is basically alternate to this, while that is alternate to that. So let's use y to name this, y to name this. Why this is x and that is x. Okay, so that's what we have. How many theorems do we have? So that's 7 theorems in all. The last theorem we have is the alternate segment theorem, where if you have a triangle in that manner and there's a tangent, then this touches the center. What that means is that the y you have at the extreme here is alternate to that, while the x here is alternate to that. So those are the theorems for a circle. Now let's analyze them one after the other. Initially we had said that angle at the center is twice the angle at the circumference. That was the first law that we mentioned. The second law says that the angle subtended at circumference by a semicircle gives you 90 degrees. The third theorem says that tangents and radii meet at 90 degrees in a circle. Now the next one says that tangents from a point have equal length. We all know what we explained as tangent and how they affect circles. Alright, now the next one we mentioned was that opposite angles in a cyclic quadrilateral give you that each of them gives you 180 degrees. So what that means is, if you remember, we also said that a cyclic quadrilateral simply means a quadrilateral in a circle. A quadrilateral in a circle. So a quadrilateral, for our review sake, is just a plane shape with 4 straight sides. That's just what it means. Now the next theorem says that angles in the same segment are equal, right? Remember the W shape. Then the last one says that alternate angles in this kind of circle are also equal, especially when you have a tangent drawn to it in this manner. So 7 theorems in all. So what do you have to do? As usual, the best thing to do in mathematics is to ensure that you practice with relevant questions. Knowing the theorem is one thing, and using them to solve practical problems is yet another. So let's look at a WAEC question that has to do with circle theorems and what we can do to identify them or use them whenever possible. So question 1, your WAEC question. This is OBJ question 1989. Question 49. So the question says, in the diagram beside of the side, O is the center. It always appears in this manner. O is the center of the circle. If triangle POQ is equal to 80 degrees and triangle PRQ is equal to 5x, find the value of x. So we have the diagram in this manner. So if I draw the diagram, you tell me the law that applies. Which law applies for this one? You remember this law, right? You do, right? So this is our 80 degrees and this is our 5x. So what law applies here? So the angle at the center of a circle is twice that at the circumference of the same circle. So that's it. So in the diagram beside, O is the center of the circle. If angle POQ, I think we should add the angles. So you have POQ. So if angle POQ is 80 degrees and angle PRQ is 5x, so you see our R at that point, we are required to find the value of x. So that's it. So I was trying to remind you of the theorem that affects this. So if you check your book where you wrote down the theorem, you could find exactly the law to follow. and the one to follow is the one that says that the angle at the center of a circle is twice that at the circumference of the circle. Okay, so what do we do? In the theorem, it is said that if what you have here, remember I said if it's 100, then the center is going to be 2 or 50 times 2, something like that. Okay, so that's it. So if whatever you have here, increases what you have, by 2 at this point. So that's what we're saying. So let's imagine that here is 100 and they have given here as 5x. What do you have to do to get the value of x? So that's what they are talking about. Okay, so what are we going to do? Remember, it is said that the angle subtended at the center of a circle is twice that at the circumference. So which means that if you have 100, it is going to be, and you want to find the other one, so this might be 2, or let's say x 50, where x is 2. So let me clean the top here so that we can solve on the top. Let me clean the top so that we can easily solve at the top here. Remember, I will ask to find the value of x. So according to the theorem, angle at the center is twice that at the circumference of a circle. Now, you see, the reason why I'm writing the angle, the theorem again, is that it is possible that sometimes you might encounter these questions in the theory part of your examination. So the best thing for you to do is to show the examiner that you know what you are doing. So the best thing for you to do is to write out the theorem. When you write the theorem, you'll be convinced that you know what you are doing. So with that theorem, if the center is 80, if 80 degrees is the center, therefore the circumference must be what? 80 times 2 is 160. So this implies that you have 5x is equal to 160. So for us to find the value of x, so you have 160 over 5. So whatever you get, let's put our answer around here. So let's divide. 5 here is 1. 5 into 16 is 3, carry 1. 5 into 10 is 5. So x is 35 degrees. So it's just for you to multiply this by 2. When you do that, you find the whole. Then you can easily find the value of x. So that becomes our solution for that. So let's look at some questions that you can practice with. So we might end with that so that you can have something to look forward to, especially as it concerns practice. So question number 1, you have that below is a circle with center C. Then BD is a diameter of the circle. A is a point on the circumference. What is the size of angle CBA? So we'll have the diagram in this manner. So each of them should remind you of what theorem we are talking about. So you have A, B, and D, and here you have 23 degrees. Here is your C. Okay, that's it. So that's the first one. So let's go straight to the second one. So I know I'm cleaning fast, but please, all you need to do is to pause, right, pause, right, pause, right. Okay, we're not supposed to stay more than 30 minutes so that you can have the rest time to practice the question. So you have a circle with center C. Then you have A and B and as well D are points on the circumference. So angle BCD is 126 degrees and angle CDA is 33 degrees. Find angle ABC. So you have a circle in this manner. So you have your A there, you have your B, you have your D, sorry. So this is the center of the circle and we'll call it C. So you have that. So you have this point, that point, and that point. So here it is 33 degrees and you have 126 degrees, then you have that. Now let it be very clearly known that if you have to show all workings, I'll be very clear about that. If you have to show all workings in circle theorem, please write the theorem first. Unless you're not getting your marks, write the theorem first before you start solving. I hope that is clear. Great. Now let's see if we have other questions to solve. So let's look at number 3. So let's look at number 3. Number 3. So you have a circle with center C. Then you have A, B, D, and E are points on the circumference. BD is a diameter of the circle. Then angle CDA is 18 degrees. That's 18 degrees, not 180, please. In fact, let me put it down very clear. So here it says find the sides of angle EDA. Right? So let's draw the diagram. So you have an angle here, A. You have another one here, B. So that's that. D. Then you have that. You have C, which is the center. Then here is 18 degrees. Then you have E here. And this is 31 degrees. So that's what you have. So let's make it 4. Let's make it 4. But this is the third question for practice. So let's make it 4. So number 4, you have a circle with center C. So you have A, E and D are points on the circumference. So AB and BD are tangents to the circle. Angle ABD is 42 degrees. Find the size of angle AED. So let's draw the circle. So you have a tangent in this manner. Does it remind you of something? So you have B, 42 degrees, and there's also a line or a chord that touches one point of a tangent on the circle to the other side. So you have your C here. Alright, so you have your E like that. Okay, lovely, not so? Good. Alright, so that's what we have, and I hope that you are going to take it seriously and work with them, because remember, for you that is taking your WAEC, there's a lot of work you have to do, especially now that you are writing your WAEC, now that you have to face mathematics in your WAEC. Okay, so that's the reason why you need to be very, very serious. Okay, so that forms the end of the class. We will try so hard to ensure that you get recurring classes. Last